Then we need to prove that mod of integration from a to b sine x over x is less than equal to 2 divided by a. Here we are going to use the second mean value theorem, right? For that we take this to be our fx and taking the other function to be, if I write here 1, it is 1 by x, right? On the closed interval ab. What is the requirement for the second mean value theorem? That both these functions should be integrable functions. So we have taken fx to be sine of x and gx to be 1 by x. Now both these are integrable functions because they are continuous everywhere. Sine x is your trigonometric function. 1 by x is your rational function. Now all the trigonometric functions, rational functions, logarithmic functions, polynomial functions, these are continuous everywhere in their domain, right? And because sin x is a trigonometric function, it is continuous everywhere, and gx 1 by x is a rational function, it is continuous everywhere in its domain, right? What the interval we are taking? We are taking the closed interval AB. For the second mean value theorem, closed interval is required, and the condition given to us is that A is strictly greater than 0 and strictly less than B. Now as there is no 0 in this interval, so sin x and gx, these are defined everywhere in this interval, right? So these are continuous functions. And because these functions are continuous everywhere, so we are saying that these are the integrable functions also. Okay, let's write this as fx and gx are integrable functions in the closed interval ab, and gx is non-negative continuous function in the closed interval ab. So therefore, by second mean value theorem, the integration from a to b, the product of these two functions is equal to, I'm taking gc outside of the integral, a to b f of x dx. For this c, that is greater than equal to a and less than equal to b. Please notice over here, if you are taking g of c outside of the integral, then there should be fx dx. And if you are using f of c outside of the integral, then inside the integral there must be gx dx. So according to the requirement, we can take fx or gx inside the integral from these two functions. This is our choice, right? Because I need to prove that this mod is less than equal to 2 divided by a. As I have taken gx to be equal to 1 by x, I know that if I put the value of any constant instead of x, I will be getting 1 by c or 1 by a, right? So that's why I'm preferring gc to be outside of this integral here, right? Okay. So writing the product of the functions now, that is sin x into 1 by x, that is sin x divided by x. So integral from a to b, this is sine of x divided by x dx. That is equal to gc is 1 by c. So this is 1 divided by c integration from a to b f of x dx, where fx is sine of x dx. So this is equal to 1 divided by c. Okay, integration of sine x is negative cos of x and the limits from a to b. So this is 1 divided by c. Putting the upper limit, we get minus of cos of b, minus, putting the lower limit, we get minus of cos of a. That becomes cos a minus cos b. Now taking the mod on both the sides, so we get this to be 1 divided by c mod of cos of a minus cos of b. And this mod is further less than equal to 1 divided by c mod of cos of a plus 1 divided by c mod of cos of b. Now absolute value of cos x can take the values from 0 to 1, right? Because here I'm having cos of a in the mod, right? And it is given that a is strictly greater than 0 and less than b. So I'm taking the absolute value of cos of a to be less than equal to 1, right? So this is further less than equal to 1. and this is also less than equal to 1. So this becomes 2 divided by c. So that means mod of integration from a to b sine of x divided by x dx is less than equal to 2 divided by c. But we need to prove that it should be less than equal to 2 divided by a, right? How to prove this? We know that c is greater than equal to a and less than equal to b, right? If I take the reciprocals, I get this. The sign changes. Very fine. Multiplying 2 all over here, we get 2 divided by a greater than equal to 2 divided by c greater than equal to 2 divided by b. So 2 divided by c is less than equal to 2 divided by a. So this is less than equal to 2 divided by a. So hence we have shown the result that this left hand side is less than equal to this right hand side, that is 2 divided by a. Hence the result. Okay, thank you. Stay blessed.